Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. Enjoy! For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number, so we need to just swap the last two around to make sure that it is even. So our answer is 7,634. If I split this shape into two sets of 6 blocks, when we're asked to shade in 3/6, for each one of those, or each set of blocks, I'm going to shade in 3 of the 6. So that's 3 for the first set, and this is 3 for the second set. And that's our answer. Now you might notice that 3 over 6 is the same as a half, because we can divide on 1 by 3, and so all I need to do is shade in a half. Or you might convert 3 over 6 into 6 over 12, and there's 12 squares altogether, so it's 6 of the 12 squares. There's lots of ways of doing this question. So this person's at Ashcook at 2017, so they're going to have missed this train here, and they're going to have missed this train here, so those are off. But they will be in time for this train here, and we're looking for the time it hits rise down. So it will get to flute at 20:52, and then rise down will be at 21:24. A comparative bar chart is where you have two bars next to each other meaning different things. So it's probably easier just to start drawing it, and then we can talk about it as we go along. So we've got males here at 12, and so what we want to do is a bar that is 12 high, and these are going up in 2s. So it will be up here. There we go. And then right next to it, we're going to do females, which is 14. And so what we're going to do is we're going to make this go up to 14. And there we go. Now, we need to be able to tell these apart. So what I'm going to do is just shade in the females. And we should do a little key. And we say that if they're not shaded, it's males. And if they're shaded, that is females. Okay, let's carry on with the bar chart. So it's 14 and 6. So notice I've got gaps between the pairs. So we've got 14 and 6, which will be down here. And again, we're just going to shade in the females. And then finally, we've got 8 and 16. So 8 would be here, then 16 would be up here, and finally obviously we're going to shade in the females. So with this question, we need to first of all count how many sides this polygon has. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 sides. And we just need to know that a 10-sided shape is a decagon. Now we are expected to know all of the names of shapes between 3 and 10 sides, so if you don't know them already, just sit down and learn them. I'm going to start just by writing down the number. And we're asked to round this to 3 significant figures, and basically what that means is starting from the left hand side, it's 3 numbers that we want. So 1, 2, 3. And we're going to do our line after that third number. And you start counting the first non-zero digit. So the first digit there was 2, so we started counting. Now all the numbers to the left, or sorry, to the right, so these numbers here, will all turn to 0. But before that happens, we look at this number. Now this number, if it's 5 or more, it moves this number up by 1. If it's less than 5, that number stays the same. Now it is 5 or more, because it is 5. So it's not going to be 207, it's going to be 208. Now, a common mistake is that students write down 208. No. All the numbers to the right of that line turn to 0. So it would be 0, 0, 0. So it would be 20,000 or 208,000 exactly. If we try to draw a quadrilateral with a pair of parallel sides, and then it's a quadrilateral, so join them up, it's got 4 sides, then the shape we draw will always be a trapezium. So our answer is that it is a trapezium. Now you might think that a rectangle and square does have one pair of parallel sides, but it actually has 2 pairs of parallel sides. The definition of a trapezium is it has just one pair of parallel sides, and any quadrilateral that has one pair of parallel sides is a trapezium. So the way these tables work is if you're looking for distance between Chauvin and Grill, you find out where the 2 of those overlap, and so they overlap at the 41. So you go down from Chauvin, left from Grill, and we get 41, and so it would be 41 miles between them. So we can either use the calculator to work out what 1.2 cubed is, or we can do 1.2 times 1.2 times 1.2. Now if you want to use the calculator to go straight there, you're going to press or type in 1.2, and then normally there's a button that looks like this, X with a little 3, okay, and that will give you the answer. Or if you're not sure how to do that, you can times it by itself 3 times, and you get the answer 1.728. The front elevation of a shape is the view you'll get if you were standing at the front. So if you imagine you're standing here, the only side you will see is this side here. And what will it look like? Well, it will look like a complete square or rectangle. And how high will it be? Well, it will be 6 centimeters high. And how wide will it be? Well, it will be 2 centimeters wide. So what we're going to do is we're going to just draw a rectangle that is 2 centimeters wide and 1, 2, 3, 4, 5, 6 centimeters tall. There we go. And make sure that you don't add any 3-dimensional aspects to it, that you don't do something like this, have some 3D stuff on it. No. Whenever you do a front elevation, it's exactly perfectly 2-dimensional. So if we look at the graph, this point here is it's the biggest. This one comes close, but it's not the biggest. So the biggest would be this one. And if we draw a line down from there, now we might think that it's enough to say Q4, but actually there's 2 Q4s here, so we must state the year as well. So Q4 in the year 2000. So we're going to start by doing a circle at -13 and a circle at -6. And x is between those values, so we're just going to join them up with a line. Probably move my circle down a little bit. Okay, next thing to do is figure out which of these dots are going to be filled in. So if it can equal that number, it gets filled in. So it can equal -13, so I'm going to fill that in. But for -6, it can't equal that, so it becomes a hollow dot. The first thing to do when working out what angle things need to be on a pie chart is to add up the frequencies. So we're going to do 14 plus 7 plus 3, and we find out that that's 24. Then we're going to find the angle that one item would be. So one item is going to be, well, there are 360 degrees in a triangle, and there are 24 items. So we're going to do 360 divided by 24, and that gives us 15 degrees. So each item is worth 15 degrees, or will take up 15 degrees. So to find out the angle for red, well, we've got 14 items, times it by 15, and that will give us 210 degrees. And we're just going to times each of these by 15, which will be 105, and the final one times 15 is 45 degrees. Add them up and they add up to 360, which is good. They need to add up to 360. So we got our protractor, rest it on the pie chart. Now we know 180 is down here, so the first thing we're going to do is just mark that on, because the first angle is going to be 210, so we know that's 180 so far. So I'm going to turn my protractor around, and from 180, 210 will be another 30, so I'm just going to plot that on. And then I'm going to join it up. So start at the center and join that up. And we're going to stop when the circle stops. Then to do 105, we're going to put our protractor in the middle. And we're going to look at 105, which will be up here. And then we're just going to join it up with a straight line. And then we're just going to check the last angle. And so if I put my protractor on it, and it is 45 degrees. Perfect. Now, an important step to not miss is you need to label them. And so the first one is red, the second one is blue, and then the final one is other. We need to first of all work out the theoretical probability. And to do that, we do the successful outcomes over the total number of outcomes. So here we're asked, it lands on a red is successful, so that's going to be 15 over the total amounts. That'd be 40 plus 30 plus 15, which is 85. Okay, now to find the expected amount, it's just the theoretical probability, which is 15 over 85, times the amount of trials, where it says it's spun 500 times. We just go times it by 500. And we get the answer of 88.235, blah, blah, blah. And we're always going to round that down. Okay, so if it's 88.9, we're always going to round it down to 88. Only when it gets to 89 do we write 89. So our answer is that we're expecting roughly 88. So we're going to track the amount of eggs to make the amount of, or to make each amount of omelette. So 5 eggs makes 17 omelettes. And we're just going to find out how much is required, how many eggs is required to make 1 omelette. So we divide that by 17, divide both sides by 17. And so 1 omelette would be 0.294 blah 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 eggs. Next we want to see how many for 67 omelettes. And to get to 67 from 1 times 67, so do that to the amount of eggs, and we get 19.705 blah blah blah. Now you can't get 0.705 of an egg, we always round with eggs, and we always round upwards, because if you need 19.7, 19 won't be enough, so we need to pick 20 eggs. So we've got to first of all find out what the gradient is for our graph. So we're just going to pick 2 points and draw a triangle between them. So I'm just going to pick this point here and this point here. And there's no reason I picked those, just pick those at random. And we look at how far it's going to cross. So it's gone across 10. How far it's gone up. So it's gone from 24 to 36. So it's gone 12 up. And to work out the gradient, which you can call n, or you can just write out the word gradient, it's change in y over change in x. So how much has y changed over how much has x changed? So y is this one here, so it's changed by 12, and x has changed by 10. So it's 12 divided by 10, which is 1.2. Now a gradient represents the amount of change in the y per one change in the x. So for every 1 mile we travel, we're going to go up, it's going to cost 1.2 more. So the interpretation that we give for this context, because this is about taxis, is that the taxi will cost £1.20 or 120 pence per 1 unit on the x per mile. And that's true for the gradient for any context. It's for every one of this, how much of this increases, how much the y increases by. So whenever we have a scatter graph, chances are we'll be drawing a line of best fit. And so that's what we'll start off with, draw a line of best fit in. And it says we're looking for a height of the box, or an estimate of the height of the box with the width of 17. So 17 is here. So the width of 17 will be a line across, let's try and get this just right, line across there. And what we do is we draw a line down when it hits the line of best fit. Now looking at the scale here, this seems to be going up in 2s. And so this line here would be at 3. In this question we've got euros and we've got pounds. And we're told that £1 is 2.23 euros. We're trying to get to understand what 2,676 euros is in pounds. And we're going to do that by finding out what 1 euro is and then finding out how much 2,676 are. So to get from 2.23 to 1, we divide by 2.23, and we're going to do that on both sides. And when we do that, we get 0.448 blah blah blah. And then to get from 1 to 2,676, we are times by 2,676 on both sides. And when we do that, we get £1,200. So 2,676 euros is £1,200. We know that when you multiply powers with the same base, and here we've got all these as base v, you add the powers. So we're actually looking at what do we add to 11, which is this one here, to get to the 15. 11 plus 4 is 15. So w therefore equals 4. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles, and corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We go first of all add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. A sample space diagram is basically a diagram that shows all the outcomes. And we've got the outcomes from spinner 2 at the top, so either 1, 2 or 3. And we've got the outcomes from spinner 1 down the side, so A, B, C, D or E. And we're just writing down all the combinations. So this will be A2, A3, and then this will be B1, C1, D1, E1, and this will be B2, C2, D2, E2, and this will be B3, C3, D3, and E3. And this represents all the possible outcomes you can get from both spinners. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half A plus B times H, and A and B are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half A plus B H. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. To find the mean, we need to work out the sum of the numbers, basically what they add up to. And what we then do is divide that by the amount of numbers. Now, what this table is telling us is there are 14 students who got a time between 0 and 4 seconds. Now, it's absolutely impossible to work out what time those students got with the information in this table. So what we need to do is we need to assume they all got, say, 0 seconds or all got 4 seconds. And the fairest value to say that they all got is what we call the midpoint. And to find the midpoint, what you do is you add up the lower bound and the upper bound, so the highest value and the lowest value, add them together and divide by 2. So 0 plus 4 divided by 2, which is just 2. And that gives us a halfway number, which is fair to everyone. So the students roughly probably got 1s, 2s and 3s, and maybe a few 4s maybe. And the average of that is going to be 2, so that's fair for everyone. Same with the 4 and the 8. Halfway between 4 and 8 is 6, and you can add them together. 12 divided by 2, which is 6. Go down finding the midpoints, and we're just going to assume the students all scored the same amount, all got the same time. Then we're going to do our FS column, okay? And so we're assuming that 14 students got a time of 2 seconds. So when you times those together, you get 28. And we're just going to times all of these together. Okay, next we're going to work out the sum of the FS. And to work that out, we just add all of these up together. So we're going to do 28 plus 36 plus 30 plus 126 plus 36. And when you add them all up, you get 256. Now, that will give us the sum of numbers. So we're going to put that into our working out now. And we need to find out how many numbers there are. Well, the frequency column will tell us how many numbers there are. So we're just going to add all of those up together. So we're going to find the sum of the frequency, which is 14 plus 6 plus 3 plus 9 plus 2, which is 34. And when we do 256 divided by 34, we get 7.529 blah blah blah. It says it wants it to 2 decimal places, so we're going to round it to 7.53. There's an awful lot going on in this question. Whenever there's an awful lot going on, it's always best to draw a diagram. So we're going to start off at Chiltern, which is a C. Then we go to Bolko, that's where we're going. And we go through Devley on the way. So we'll do D there. Distance from Chiltern to Devley is 34 miles. Distance from Devley to Bovlow is 16 miles. So I'm just reading through the question, adding it to my diagram. David leaves Chiltern at 9 o'clock. He drives from Chiltern to Devley an average speed of 68 miles per hour. And what speed does David travel between Devley and Bolko to arrive at 9:45? So the whole duration of this, the whole thing needs to be 45 minutes or 0.75 hours. And the entire distance is 34 plus 16, so that would be 50 miles. Okay, now having a look at this, we need to find out what time David was at Devley. So we're going to use our speed distance time triangle. So speed equals distance over time. And we're covering up the time because that's the one we want. So it's going to be time equals distance, which is 34, over speed, which is 68. So we're going to do 34 divided by 68, which is 0.5. So it would be 0.5 hours. So that would be half an hour. So we will be at Devley at 9:30. So that means we've got 15 minutes left. Okay, so we've got 15 minutes to travel the 16 miles. So this time we're looking for the speed. Okay, so it would be speed equals the distance, which is 16 miles, over time, which is 15 minutes, but we need that in hours, so that'd be 0.25 hours. And so what we can do here is times top 1 by 4 to get rid of the fraction. So it becomes 64 over 1, or just 64 miles per hour. So our answer is 64 miles per hour. I'm just going to write the question out, so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside, so we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. So if we imagine we've got the 25 meter pipe here, and we've got the 35 meter pipe here. The question's basically asking us, what can we cut all these pipes into, and they all have to be the same length, that will fit with the 25 meter and the 35 meter. And essentially what this question's asking is, what is the highest common factor of 25 and 35? So to find the highest common factor, what we do is we just find the factors of 25, which is 1 and 25 and 5 and 5, and the factors of 35, which will be 1 and 35 and 5 and 7. And the highest common factor is the number in both lists, the highest number in both lists, so it's 5. So what we can do is we can cut all of these pipes into 5 meter pipes. So 1, 2, 3, 4, not to scale, and then 7 of these. So 1, 2, 4, 5, 6, and so there's 7 in total. So each of these are 5 meter long, and there's no wastage. And that's the longest we can make the pipes for there to be no wastage at all. So my answer is 5 meters. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation, but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals, and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now, in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be 1/3, x could be anything. So I'm going to start just by writing out the equation, and I can put my lines in. Okay, we're asked to make x the subject, so we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says to expand your answer fully, so we're just going to expand the brackets. 7m plus 70. When finding a sample of people, you want everyone in the population to have an equal chance of being picked. So in method 1, the fact in a lifestyle magazine might bias the people reading it, because there's groups of people that don't read lifestyle magazines. A poster up in the gym, again, there's groups of people who don't go to the gym. And midday in town centres, well, it might be on a school day, or it might be that you are skewing your data towards retired people. There's lots of reasons why a certain group of people won't be at a town centre at midday. The only one here that gives everyone an equal chance of being picked is this one here. Okay, so picking people randomly from the electoral roll. There are some groups of people who might choose not to be on the electoral roll, but looking at the 4 methods, this one is by far the most fair sample. The important thing when choosing a sample is that everyone has an equal chance of being picked. So if you look at method 1, picking the first 30 students who enter the school is going to have a bias, because there might be a difference in the type of person who arrives early to school to the type of person who might arrive later. If we select a class in the school, then they're generally all going to be the same age. So if it's a year 7 class or a year 11 class, they're all going to be the same age. It might seem that it's fair that picking the first 30 students alphabetically, so A to F or whatever, again, that's not fair, because the people at the end of the register don't have an equal chance of being picked. So you need to make sure everyone in your population has an equal chance of being picked. So picking 30 students out of a hat containing all the students' names in is definitely the fairest way of picking a sample from this list. So we're going to write out the question again, just to give us a bit more space. And we're going to put in our tramline so we can solve it. Now we're going to solve this in exactly the same way as if it was an equation with an equals in the middle. One slight difference though is if you times or divide by a negative, you've got to flip the sign, but hopefully we won't do that. Now the rule when you've got an x's on both sides is you get rid of the smaller amount. So we're going to get rid of that 4x from both sides. We're going to take away 4x both sides. And so we're going to have 3x plus 8 is greater than 23. And then we're just going to solve this normally. So take away 8 both sides. And that will give us 3x is greater than 15. And then we're going to divide the 3 both sides. And that will be x is greater than 5. So we're going to start off with x equals 0. And we're going to write out this equation, but with 0 every time it says x. So it's going to be y equals 0 squared minus 0 plus 10. Well, 0 squared is just 0, so 0 take away 0 is just 0, plus 10 is just going to be 10. So the answer there would be 10. Could do the same for 1. So it would be 1 squared minus 1 plus 10. Well, 1 squared is 1, 1 take away 1 is 0, plus 10 is 10. So that will also be 10. 2 squared minus 2 plus 10. 2 squared is 4, 4 take away 2 is 2, plus 10 will be 12. Now we're going to do the negative, so we're going to look at minus 1. So it's y equals minus 1 squared, and it's going to be minus minus 1 plus 10. So a little bit more complicated here. Minus 1 squared is just 1. Now here you have two negatives together. When you have two negatives together, it makes a plus. So we've got 1 plus 1 plus 10, which is going to be 12. And then we'll do the minus 2, so it'd be minus 2 squared minus minus 2 plus 10. So minus 2 squared is 4. The two minuses here make a plus, so it'd be plus 2, which would be 6, plus 10 will be 16. So we're going to plot these on our graph. And so we've got minus 2 is at 16, so that'll be there. Minus 1 is at 12, which should be here. 0 is at 10, 1 is at 10, and 2 is at 12. Okay, when you join this up, things to be aware of is you need to make sure that you have a round U at the bottom and not a flat bottom. Okay, so you want to avoid a flat bottom. You also want to make sure that you avoid feathering like that. You want just one nice smooth line. And my recommendation is always to turn the page on its side. I don't have that luxury, so I'm going to try my best with this. But you need to make sure it goes through all the points. And here's the part here where it goes beneath those 2 points. So make sure it goes beneath those 2 points. On most exams, I see them, basically what they do is they draw a line across from those 2 points and say that the line needs to go beneath that, or your curve needs to go beneath that line. So they're looking out that you've gone beneath the line. To find the exterior angle of any polygon, we do 360 divided by the amount of sides. These are decagons, which means they have 10 sides. So the exterior angles will be 36 degrees. And the exterior angle is just an angle that kind of continues on. You just continue on from the side. So this one here is the exterior angle of the left-hand decagon, and this one here is the exterior angle on the right-hand decagon. So altogether, the angle A will be 36 plus 36, which will be 72. So our answer will be 72 degrees. We can keep this as an interior angle, but it's actually sometimes easier to convert it to an exterior angle. And what you might know is that the sum of interior and exterior angles is going to be 180 because they will always form a straight line. So to find the exterior angle, all we need to do is 180 take away the 170, and that means it will be 10 degrees. So we've already done a different formula for exterior angle, which is 360 divided by n. And something we can do is we can just swap these two things around. And so we can make the formula that n equals 360 divided by the exterior angle. So 360 divided by the exterior angle, well, we know that the exterior angle is 10, therefore n is 360 divided by 10, which would be 36. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angle triangle. So a squared plus b squared equals c squared. And A and B were labelled. C is always opposite the right angle, so it'd be 49 squared plus B squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have A, we've got our B, and we're going to call X the C. So it'd be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148. We've just worked that out. And we're looking for c. In fact, we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared. And we just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its two decimal places, so that will be 61.19. We can write the equations of all linear graphs as y equals mx plus c, with m being the gradient and c being the y-intercept. The easiest thing to find is the y-intercept, because it's just where the line crosses the y-axis, so that's going to be -2. We're going to use that point, so the point we've just drawn on, and we're going to have to find another point to find the gradient. Now, I don't really like this point because I don't really know where that is, and we've got to find a coordinate we know the coordinates for. So looking at this, this is a nice coordinate here. And what I'm going to do is just draw a right angle triangle between the 2 points. Try and get it as nice as I can. And we're going to work out how far up and how far right we went. Well, we went 3 right and 4 up. Now, to find the gradient, what we want to do is we find out how much y has changed, so change in y, so that's how far up it's gone, which is 4, and put that over how far right it's gone, so the change in x, which is going to be 3. So our equation is going to be y equals 4 over 3 x minus 2. So here we're asked to factorise a quadratic, and our answer will be x plus or minus something, x plus or minus something. So it'll be 2 sets of brackets with an x at the start. Okay, so to be able to find out what's in the bracket, we look at the 36 there, and we know that we're going to have to multiply 2 numbers together to make that 36. And we look at the coefficient of the x, that 15, and we know we're going to have to add these numbers together to make that 15. Now, if you just can figure out in your head the answer, that's absolutely fine. If not, you can just quickly write down the factors of 36. Now, because they multiply together to make a positive 36, they'll either both be positive or both be negative, but they add together to make a positive number. So we're just looking at the positive factors. So 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. And we're looking for which ones of those add together to make 15. And we can see here it's going to be 3 and 12 add together to make 15. So our 2 numbers are going to be plus 3 and plus 12, or the other way around. It's important to remember our speed, distance, time triangle. So we've got speed equals distance over time. And here we are given a distance because from here we're 16 kilometers away from home. So the distance, let's just draw another triangle, the distance will be 16. And we're told that the speed is 32 kilometers per hour. So the speed is 32. So to find the time, we're going to do 16 divided by 32. So the time is a half an hour. And half an hour would bring us, if we start here, half an hour would bring us to 2030, because it's 8 o'clock where we start and we end, therefore, half an hour later. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the graph, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly, because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thin, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. When proving two triangles are congruent, and congruent means exactly the same, we're going to have one of four answers. Either side angle side is the same, angle angle side, or angle side angle. Side 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 are the same, or they have the same right angle, hypotenuse, and side. This question doesn't have a right angle, so we can cross that out. It has two lengths, so two sides, but not three, so we can cross that one out. It only has one angle, so we can cross this one out. So we're looking to see whether it has the same side, then angle, then side. So here we've got 13 as a side, then 139 as an angle, then 6 as a side. 13 as a side, 139 as an angle, and then 6 as a side. So they have the side, angle, side. So 7 times 10 to the power 4 is going to be 7, and it's going to be 70,000. And 9 times 10 to the power of 7 will be 90 million. And so when you add them together, you get 900700000. Now, if you have access to a calculator, if this is on the calculator paper, then you can just type it into your calculator. Some people think there's a quick way of doing this, like adding the 7 and the 9. There isn't. You've just got to work out what this number is, work out what this number is, and add them together. So we're going to start by understanding that all lines form, or can form an equation y equals mx plus c, with m being the gradient and c being the y-intercept. It says here the gradient is -2, so we've already got a bit of a head start with this, but we don't know what the y-intercept is. So we're going to use this first set of coordinates to work out what the y-intercept is. So y is -31, and x is 15. And we're going to use this to solve and find out what c is. So first thing I'm going to do is, well, just tidy this up. 2 times 15 is 30, so -30 plus c. And I'm just going to add 30 to both sides to get c on its own. So that would be -1 equals c. So c is -1. So we now know that the equation is y equals -2x minus 1. And we're told that the y is -37. And we're looking for the x value, which they've called w. So let's get our solving lines in. Okay, so the first thing I'm going to do is add 1 to both sides. And so it would be -36 equals -2x. I'm going to now times, or divide everything by -2. And a negative divided by a negative is positive. 36 divided by 2 is 18. And then obviously that gets rid of the coefficient of the x, so it's just x. So x equals 18. So the x value is 18, and the x value is the w value. So w is 18. To find the probability that this person was wearing a red item, we need to work out the amount of red in total, and the total amount of people. So the success is red, so we're looking at red. So 7 plus the 4, which is 11. And the total amount is the 10 plus the 7 plus the 4 plus the 2. So we're going to add all those together. We make 23. So our answer is 11 over 23. Any number to the power of 0 is equal to 1. So it doesn't matter if it's a number or a letter, it's always going to equal to 1. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10, 990. Now when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it was 11,005, it would have rounded up to 11,010. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power 4 w to the power 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power 4 w to the power 5. Some people will try and do something with the v to the power 4 w to the power 5, but if you think about it, if I just draw out my square, if it's 11v to the power 4 w to the power 5 all the way around, when you add, you don't add the v to the power 4, w to the power 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power 4, w to the power 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power 4, w to the power 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. To work out the area of this sector, there is actually a nice little formula that we can use, and I'm just going to show you what the formula means. So the formula is going to be what fraction of the full circle do we have. Okay, so we're going to find out the fraction of the full circle we have, and then we're going to times that by the area of the circle. So to work out the fraction of the circle we have, we get the angle that we have in the sector, and we divide that by the total amount of angles in a circle, which is 360. Then we times that by the area of a circle, so pi r squared. Let's use that for our question. So the angle we have for this question is 57. Times pi r. Now, to work out what r is, we just imagine the circle is whole. I'll do a badly drawn circle. And you can see here that this length here, this 5 centimeters, is the distance between the center of the circle and the circumference. So that is a radius. So it's going to be times 5 squared. Put that into your calculator and you'll get 12.435 blah blah blah. And it says it wants its 2 decimal places, so we round that to 12.44 centimeters squared. With this question, you've just got to know what the different functions look like. So with C and D, we've got quadratic functions. One's a positive quadratic, which is a U shape. One's a negative quadratic, which is a kind of upside down U shape or an N shape. And here we don't have that, so we can get rid of those in our thoughts straight away. A is a positive cubic, which goes up, then down, then up again. And B is a negative cubic, which goes down, up, and then down again. So this one here goes up, down, up again. That's going to be a positive cubic. So our answer is A. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be -2. So what I'm going to do is I'm just going to put my rearranging lines in. And we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that that gives us. So it comes down here, and it comes down here. So the values it comes down to are minus 1.6 and 0.8. And those are our solutions. Okay, so we're going to start off by working out the multiplier, and we're told, we always start off with 100%, we're told that the compound interest rate is 1.6%, so we're going to add 1.6% to the 100%, and it's going to be 101.6%. Okay, make that into a decimal by dividing it by 100, so we're just going to divide that by 100, and this will give us the decimal or the multiplier. So the multiplier is 1.016, and so anytime we want to increase something by 1.6%, we just times it by 1.016. Now, we're told that we start off with 2,400, that's our original amount, and to find out what it's going to be in the savings account at the end of the first year, we just times it by the multiplier, 1.016. But we're told that it's for 7 years that it's going to be in there. So we then times it by 1.016 times, or easier way of doing it is 1.016 to the power of 7. When we do that, we get 2,682.052 blah blah blah. And because it's money, we round to the nearest pence, so 2,682.05. To be able to work out this question, we need to work out the amount of student hours required to paint the wall. And to work that out, we've got 6 students and it takes them 11 hours. So 6 times 11 means it's going to take 66 student hours. So if we had 1 student, it would take 66 hours. 2 students would be half of that because they share the work, and etc, etc. So here we've got 6 students and take 11 hours. And it says how long will it take 7 students? Well, if there's 66 hours, or student hours, but they're sharing the time, we just divide 66 by 7. So 66 divided by 7 is 9.428, blah, blah, blah. And it says it wants its 2 decimal places, so it will take them 9.43 hours. Now check this makes sense. We've got 6 students and it takes them 11 hours. So we'd think if we had more students helping to paint the wall, it would take less hours. So we've gone from 11 hours to about 9.5. So that sounds right. It doesn't look like it, but we actually have a quadratic here. And the reason it doesn't look like it is because we don't have an x term. But as long as we have an x squared term and a number term, we definitely have a quadratic. And notice something about this second number. It's a negative version of a square number, and that will always be the case because this question is using something called difference of 2 squareds. And it's very, very simple to work out. What you do is you put down 2 sets of brackets and you square root the first term. Well, that's just going to be x. And you put the positive and negative versions of the square root. So we're going to square root 121, which is 11. So we're going to put plus 11 and minus 11, and that's it. Now, when we expand that, and we'll just go quickly expand that now to have a look, it's going to be x squared plus 11x minus 11x minus 121. And notice that the 2x terms cancel each other out, which is why we don't have the x terms. So what's happened here is that the company's increased the amount of Swedes by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100%, and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now, they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. It's sometimes easier in these questions to view these triangles as 2 separate triangles rather than one triangle. So we're kind of just going to split this triangle off and just move it to the side so we can see what's going on. I'm going to do the same with the smaller triangle and kind of move that to the side. So we can see we've got 2 triangles here. We've got a big triangle and small triangle. And we can label the sides of them as 18. Now this long length would be 20 plus x, 20 centimeters plus x. Then we've got 6 here and we've got x here. Now the 2 triangles are similar because the sides here we assume are, we know they are parallel because they are right angles, and they share an angle here, which we can just label as A. And so they are definitely similar, which means that one is an enlargement of the other. So we need the scale factor first. Now if you look at the 6 and the 18, they are what we call corresponding sides. So we need to work out the scale factor by finding out what I multiply the 6 by to get to the 18. Well, that's obviously going to be 3. So we now know that we can times the x by 3 to get to the 20 plus x. So we can write that down. 3x, I'm timesing the x by 3, and that will give me 20 plus x. And so I can solve this now. Subtract x both sides. Always subtract the smaller amount, so 2x equals 20. And then divide both sides by 2. And so we've got x equals 10. So we know that x equals 10, it says find the length x, and so that will be 10. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. So we're asked to find the bearing of Freetown from Gamley. So that is this angle here. And so what we're going to do is we're going to find this angle, and this will obviously be 90 degrees because the hiker walked west, and it's against the west line and the north line, so it's definitely 90 degrees. So we can work out what the bearing is if we know that angle inside the triangle. So we're going to start by labelling the sides. Well, we've got 90 degrees here, we've got hypotenuse here, we've got the adjacent here next to the angle, and we've got the opposite, which is across from the marked angle. Here we're not using the hypotenuse, so we can cross that out. And we can do our SOHCAHTOA. And the only one that doesn't have the hypotenuse is TOA. And so we're doing tan x equals the opposite, which is 49 over 98. Get our lines in. And we're going to do the inverse tan to both sides. So we get x equals, and we do inverse tan, which is 26.565, blah, blah, blah. Okay, so we know that the whole of the way around up until this point is 270 because we've got this 90 degree left. So what I'm going to do now is we're just going to work out the bearing. So bearing, we're just going to do 270, take away the 26.565, blah, blah, blah. And that gives us 243.434, blah, blah, blah. It says it wants it to the nearest whole number, so that's going to be 243. So there are 3 parts that we need to find the area of. We're going to start with the easiest bit first, this circle at the bottom here. Okay, so the circle area is just going to be pi times r squared. And the radius is given to us at the top, which is 9. So it's just going to be pi times 9 squared. And that would be 254.469, blah, blah, blah. Or we could leave it as 81 pi. Next bit is the curved bit of the cylinder. So we're going to do the cylinder next. And it's just the curved bit, and the formula for that is 2 pi RH. So 2 times pi times the radius, which is 9, times the height, which is 30. And that will give us 1696.460 blah blah blah. And the last bit is this hemisphere here. And so let's do the hemisphere. And the formula for the area of a hemisphere, well, this full sphere is 4 times pi times r squared, but because it's a hemisphere, it's half of that. And so it'd be half times 4 times pi times the 9 squared. And that will give us 508.938. And so the final thing is to work out the total area, so total surface area. And we're just going to add up all these numbers together. So we add up the 254.469, the 1696.460, blah, 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 and the 508.938, blah, 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 blah. And we get 2,459.867, blah, blah, blah. Do make sure you show the examiner that you're adding these three here. I've not done that because it wastes a bit of time for a video, but make sure you write it down. It says it wants it to 2 decimal places, so that will be 2,459.87 centimetres squared. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.